Our final work with arithmetic sequences is to find the sum of a finite arithmetic sequence. So we can only find the sum if we, have a finite number of terms rather than infinite for an arithmetic sequence. So we're going to, use a formula for that. And our formula is actually based on the formula of a rectangle. Sorry, of a trapezoid. Not a rectangle, a trapezoid. And so if you think about, here's the first term of a arithmetic sequence. Okay, maybe it's 5 or something. Each term you add on the same amount. So if you add 1, then you add 1 again, then you add 1 again, and you add 1 again. That's why really it increases linearly, right? Because you're adding the common difference every time. So this over here is a sub n. And the number of times that you've added that on is n, right? You've added it on n times. So the formula, just like a trapezoid, is the sum of the n terms is equal to a sub 1 plus a sub n divided by 2 times n. Okay, so remember a trapezoid was base 1 plus base 2 divided by 2, so it's kind of the average of the bases, and then times the height. And the height in this case is n, it's the number of terms. Okay, so this is a useful and simple formula to use. So let's do an example of using this term. So we have this sequence, 8 plus 11 plus 14 plus dot 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 plus 3n plus 5. Okay, so they're giving us the formula of how to calculate each term, right? And this can be written as the sum of from k equals 1 to n of 3k plus 5, right? It's the same, we can write it out as a sum, or we can write it in summation notation. Okay, well, to actually find the sum, now we're not going to have a number answer because n is going to be involved, so whatever n is, it depends on that n. But we can use this formula. So we know that a sub 1 is equal to 8, right? We know that a sub n is equal to 3n plus 5. 3n plus 5. Okay? We also know n, right? Because this is, since it's in terms of n still, n is just going to equal n. So the sum of the first n terms is going to be 8 plus 3n plus 5, all divided by 2 times n. Okay, we can simplify that a little bit and have our answer. So 8 plus 5 is 13 plus 3n over 2 times n. You can leave it like this, or you can multiply the n in even a little more. So 13n plus 3n squared over 2. Okay? So again, it has to be left in terms of n because they didn't tell us the actual number that n was. Now, in another example, one last example, this section, we actually do know what the nth term is. So let's look at that. So here is our sequence, example 2. 60 plus 64 plus 68 plus 72 plus dot 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 plus 120. Okay, no n, just 120 there. Okay, so we are supposed to find the sum. Okay, now one thing I can see that we do know a sub 1, which is 60, and we know a sub n, which is 120, right? So awesome. The thing we don't know is n. How many terms are there here, right? So we have to figure out n. before we can use the formula. Because it is a number. I mean, 1, 2, 3, 4 terms. We have 5 terms listed here. Obviously, there's a bunch of terms between 72 and 120. If you have some like clever way of finding how many terms that is, go ahead and do it. This is just one way to do this. So what I'm noticing is the common difference is 4, right? We're adding 4 to each term, right? So D is equal to 4. So I could write a little formula for this sequence, and I think I could find N. Okay, so for 120, right? 120 is the term, and then the first term is 60, and then we do plus D times N minus 1. Right? This is just a regular arithmetic formula. A sub n is equal to a sub 1 plus d times n minus 1. Okay, I'm just using that formula, plugging in that 120th term, because then I can find out which term it is. Okay, sorry, it's not the 120th term. It's the term that is 120, right? Okay, so right now I'm thinking I could just subtract this over. So 60 equals 4 times n minus 1. I could divide by 4, which would be what, 15? Yeah, 15 is equal to n minus 1, add 1, so n is 16. Okay, so now I can easily find the sum of the first 16 terms, right? So this is n equals 16. Okay, that's what that meant when we found that. So the sum of the first 16 terms is going to be the first term plus that 16th term over 2 and times 16, okay, times n. So I'm looking at 60 plus 120 is 180 over 2 times 16, or 90 times 16, which is 1,440. Okay,